Sorry, the previous video cut off in the middle. I'm not quite sure why, but let's pick up where we were. So what do we want to do? We want to say that 4x squared, we can rewrite that as 2x quantity squared there. So this is going to be suggestive that we should be setting u is equal to 2x. Because then we'd be looking at the square root of u squared minus 1 in that denominator, and that's basically what we're looking for. U is equal to 2x, and x is equal to u over 2. So we crunch out the rest of this, we get du is equal to 2 dx, or du over 2 is equal to dx. And now we just have to make all of the replacements here. So dx becomes du over 2. And then the square root of 4 minus x squared minus 1, that just becomes square root of u squared minus 1. The x in the denominator, that becomes u over 2. And then when we replace the bounds, when x is 1, u is 2 times 1 is 2. When x is root 2 over 2, u is 2 times root 2 over 2 is just root 2. So this is how we set up our integral. This is how we convert everything. We can do a little bit of simplification here. Those 1/2s cancel. And now we do exactly match this formula here that we are integrating. So dx over absolute value x, as we already said, we don't have to worry about the absolute value here, times square root of x squared minus 1. These two match perfectly. So what is going to be our answer here? So we are... The answer is going to be arcsecant x, and then plug in root 2 and 2 there. So this is what is going on. So what do we have here? We have arcsecant of 2 minus arcsecant of square root 2. Okay, so we could stop here if we wanted to. I do think it is worthwhile to actually think about both of these values of arcsecant are actually ones that we should know. So really, so the calculus here is done, but I do think it is good practice for us to finish off the calculations here to get this in terms of pi's and stuff like that. So arcsecant of 2, this is really asking when is secant x equal to 2? And secant, of course, is 1 over cosine. When is 1 over cosine x equal to 2? And that is when cosine x is equal to 1/2. So the arcsecant of square root 2, this is asking when is secant x equal to square root 2, which is really asking when is 1 over cosine x equal to square root 2, which is asking when is cosine x equal to 1 over square root 2, which is root 2 over 2. And so both of these should be things that we should know. We should know that when x is pi over 3, when x is pi over 3, cosine of pi over 3 is 1/2. When x is pi over 4, cosine of pi over 4 is root 2 over 2. So our final answer here is pi over 3 minus pi over 4 is pi over 12. That is our final answer for this problem.